Hey guys, sorry I couldn't upload that video yesterday, so I kind of made a different one, but it's about the same thing. Um, but what it's about is that these Birkeland currents are what I believe made the planet. And the reason I think they're Birkeland currents, or images of Birkeland currents, is because they go over one another. You can see that this clearly goes right over this one. And then it wraps around and it looks like it breaks off actually right there, and here another one, and even here. So that's why I think they're Birkeland currents, and Birkeland currents are filaments that in the electric universe they power up the stars, the planets, like circuits, and they're plasma and they're made out of electrical. And now what I'm claiming in this video is that, okay, in order to test this hypothesis or whatever, it would mean that this would have to match everything. If this made the entire planet, then the entire planet should match to these Birkeland currents. And that's what this video is about. This is the shortened version of what I was going to put out yesterday. I just want to show you something really quick right out the gate. What I'm looking for, what gets my attention, is things that are shaped like this triangle. It has this certain type of angle to it. That usually is an indicator that it's related to this. And then when I line them up, I usually find out that the rest of this stuff lines up too. So, and I'll show you, here's an example. Just sitting right next to it, you can see what looks kind of like that triangle thing right here. And this is what I'm talking about lining up, is you can see that these lines right here all play a role with these Birkeland currents that are wrapping around one another. So see how that just fits up into there, and then that fits there. Well, this is the beginning of the process I was telling you created the planet. That's what I'm going to try and do, is align this up as many times as I can as I go. And right here is no exception. As a matter of fact, I think there's a piece that was missing right here. This part that's looks like it's been busted off. Okay, let's take sometimes the faraway shots are better for looking at stuff, because you can see the broader picture. But you can see right here and there, of course, but you can see how as this comes in, you can see that this fits into there, right? And then if you keep going, you can see that, yeah, right here on the bottom. Okay, you see that? It fits right through, comes out this bottom, and it's got the same design right here. Okay, so that means that, and then look, this, as that fits there now, and this is starting to fit into here. See how that fits into there now? Okay, and you saw how it fit here, along in here. But then what happens if I take it up here? Well, you can see it fits again, right there. Okay, so this is just starting out. This is right next to it. And as you can see, this fits also over here. This is Cuba. These Birkeland currents are rotating. Okay, they're rotating and stuff is coming out of it, and it's moving along. See how now it fits again in here. This thing, you can even see the underlying features here with that eye. Okay, and you can see that this part that comes out the top of it, you can see it lines up in here, and you have what looks like a splitting, right? Which would explain why that's being broke off to begin with. And I did say it would line up everywhere. And I meant that, actually. You can see this right here. You can see it's fitting in there. The twisting, you can see that, right? It's kind of cool. You can actually see the twisting in process here. And then let's see, I haven't even tried this alignment yet. This is Florida right there. You can see that that eye right there fits right into there. You can see that this fits right into here. And you can see it fits here, and if I reverse it, you can see that it fits in here. And then when that fits in there, I can take it again and fit it right in here. It fits here, of course, these Birkeland currents, and it lines up. See that right there? And it's going to line up again. And again, and again, and again. And no matter how I do this, see how this, look at how the current fills right into there? Like that. If I go like that, go like that, it fits. It really doesn't even matter. This thing's going to fit no matter what. Right there. See what I'm saying? This thing right here. See how that fits right there like no problem? This thing fits everywhere because it made the planet. Right there. See that? Check this out. There's Florida right there. The two dots. You got dots right here. You got dots on Florida. They're lakes, but they line up. And these filaments line up no matter what. Okay, so I want to make sure I get this well so that everybody knows exactly what I'm saying here. Okay, so we got that. It's gonna line up everywhere, even here. You can see this is twisting around it. Okay, here's North America and these Birkeland currents in South America, and just like that, they're coming in. Florida seems to line right up with the Amazon River. And this Birkeland currents seem to line right up with this area right here. Pretty damn good too. But not just there, but also here. Pretty good like that. And then when you jump it across, you can actually see what made this right here. You see how they got these two, notches out? Well, Birkeland currents made those because they're wrapping around it. You can see it right there. And you can see where it's missing. You see, watch as I bring it in. Let's get closer, make sure. That's what made the Baja of California here, or this peninsula. right? You can see that. See that when I move it in more, it still lines up. And you can see that it's rotating. So this will match reverse too. But let's see though. Look, as this lines up here. Take a look right here. We got the Grand Canyon right here with its discharge pattern. Lining up a little bit with South America here, because that's what blew out the Grand Canyon at one time. It doesn't matter if there's fossils in there or what. The fact that it lines up really is all that matters. You can see, let's see what else. Yeah, as this lines up here, oh yeah, you see this, how it's spinning and all that. Well, take a look at the Amazon River as it lines up with the Great Lakes, because I believe this discharge is rotating and it's gouging out these lakes. That, or it's a walking discharge where it's actually got what looks like legs, and as the planet or as the core rotates, it'll look like it's taking steps each time it rotates more and more. But I think this is more related to rotating. Now look at the Mississippi Delta. Or you could tell that rotation would play a huge factor in the shape of that, because you have feet on both sides, and which would be this rotating would cause this kind of a shape, right? If you think about it, see how it fits on that one side if it's rotating. But you got to remember, this is also going to be three-dimensional, and that's the problem that plates puts on people's brains, is that when they look at the land features, they only see them as flat and two-dimensional, but there's 3 dimensions here. And there's Florida with its lake right here, and matching up with the discharge. See how this one, and not just with the discharge, but with the filaments too, right? You see how that works out? And then of course you've got Gulf of Mexico, which they claim is they claim that the meteor that hit this area killed the dinosaurs. Well, I can show you that no meteor hit this. What hit this was this vortex. I have a whole thing about this, by the way. Look at see how that fits into there? You see how this fits everywhere. There, and then I have to get the East Coast, but you see this, right? This is just the beginning. You have no idea what's. Wait till you see how well I can fit this over any part of the planet. Okay, I want to show you now Japan with those Birkeland Current mountains. Check it out. You can already tell that this looks a lot like that. But the cool thing is as I bring it in, you see the mountains, and then you see this area right here. Well, as I line that up, you can see it fits in there in that opening. But you can also see that Japan has these lakes or whatever, and you can see these land features here by South America line up exactly. You got the round part right here. It's exact. And to prove it, see how it fits in there exactly? Well, then you got this. This area right here, you can see how it fits into there. And then when it fits into there, and those islands fit into here, you can see that this fits into there, and you know, you can tell that this is it. And then, of course, if you look right here, you can see that these lines line up with these underneath lines. Even the faint ones. Let's see. Hold on, I gotta get back for that one. Go. Yeah, like that. But you can see that it just lines up. It is what it is. Then yeah, notice like right even in here when that lines up, see these lines right here? And I'm sure there's more. Let me see. Oh yeah, hold on. Let's get these lined up again. Right in there. But see, what's trippy about this is that this is underneath this layer. These markings, this is supposedly a subduction zone. So they have a problem right now. They have to play tectonics, or anybody that watches this video can try to explain to me how this can fit on a subduction zone. When this plate's subducting and being destroyed underneath this plate according to plate tectonics, how is it possible that I can have an alignment of another continent half a world away on the top of a subduction zone? And here, let's get this lined up right. When I line this up again, check this out. I line this up here. You take a look at the Amazon River right here, and below it you have those Birkeland, what I'm claiming are images of a Birkeland current wrapping around and pinching and breaking apart, which I think is the North and South Pole being created. But check it out. Look at how good the Amazon River discharge pattern follows that when this lines up. Even all the way to the end, look at that. You can see the other patterns too also fit in with the markings here. Seriously, look how it follows this filament. You think that's a coincidence? This is half world away. And even in the look, even in the other background right here, you can see the details of it. That's remarkable. And I mean, just look at that. It's crazy. Man, did I call this or what? There's no way that a river would line up with that randomly. And then I'm sure there's even more. There's more. Oh yeah. These right here are other, like the beginning of this in stages, and you can see they line up too. And then look, you look at the background here. When I move it in, you can see it also lines up too. This lines up right there with that darkened area. And over here, you can see these line up there. And you can see, look, the way these lines run this way, and so do they run on, like here. See that? That's a match. And then of course you got other back. See how that, and then this. Yeah, it lines up like right there. But you can see the swirling right here. But it gets even better. Check it out, because sorry about moving it back and forth, but because when you look over here, let's see, where is it? I recognize this very edge right here. This is the Mid-Atlantic Ridge, and I recognize what part it is. And see what it lines up with? It's lining up with this thing right here. So this is how I find a lot of my reoccurring patterns this way, by lining up ones, and then I'll find other ones on, nearby. And check this out. Okay, so here is the Mid-Atlantic Ridge right here, and this is the feature that I recognize there. Here's that same thing right here, this feature right here, and it lines up now with the Mid-Atlantic Ridge like such. Look, you can see that this is feeding into that, and then this then fits right into there, and then as it fits, this runs along the Mid-Atlantic Ridge. You can see how it curves right here. That means that the Mid-Atlantic Ridge isn't spreading, because why would this line up with it when it's on the other side of the planet? And it lines up well with it too, because look, see, when you push it off like this and this thing hits it, because it obviously has moved, you can see how it lines up with these features here like that. See? Oh wow. And then here you go, here's Australia, and you know how you have the squares right here. This is a square shape, this is a square shape. Well, now you know where the square shape came from, because look, you can see the you can see it. Look, hold on. See how it even curves like the. See the leg? Right here. So it goes like that, huh? See how it fits up right there? You can even see that. Look, see that surface feature, how it lines up right in there. You even got this volcano here. You move it over far enough and it lines up with other ones. Yeah, when it lines up there, you can see this lines up again with this dot right here. This just goes on and on and on. It'll keep lining up over and over again with other things. Yeah, one last thing about the Japan area is, you know how I had matched this up like this, all in here? Well, if you look at this area, you'll notice that it's got a crisscross pattern running through it. And I've showed this before in other videos in other areas of the planet, that this crisscross means that there's been a flip-flop, like a reversal. And so then you take that image that I was lining up before, and I flip it backwards, because it's like a vortex. It rotates, so you're going to get a front and a back side of these alignments. And when I do that, I realign this up, and you can see that this right here is this right there, Cuba, and that trench. And that when you look at this, you'll see that it also lines up here now. If I can show you it, hold on. This area right here. See right there, just like that. That's pretty solid, actually. And anybody's welcome to go ahead and discredit any of this. Thanks for watching, and there's a lot more. This lines up everywhere.